Hi everyone, welcome to my channel, Bhakti and Sairaj. In this video, what are we going to understand about the Newton's law of gravitation, also known as gravitational law. So we all know that this is the Newton's law of gravitation which he gave. Now what does this law means? What does this formula means? We are going to learn the derivation of this formula. So very first thing, what Newton said in this law of gravitation. Newton said that if there are two objects, let's say there are two balls, okay, they are having mass, let's say this is m1 and this is m2. I'll be explaining you with the examples as well. There are two objects. Listen very carefully what did Newton said. He said there are two objects with mass m and with mass m2, and the distance between them, but distance should be from the center. Let's say this is the center of these balls and we join this center, and the distance we get is r. The distance we get is r, but we will take this distance r as r square. I will let you know why r square. Alright, the distance is r. Now let's take by numbers. Let's say m1 is 50 kg and this m2 is, let's say, 60 kg. Okay, this is made up of metal, this is made up of any inferior metal, this is quite heavy, and the distance between them is, let's say, 2 meter. The distance between them is 2 meter, so you will write it as 2 meter, and here we mostly take distance as distance square, so 2 meter square. Now what is the formula? Okay, let the formula go. Just understand this. And then what did Newton said? F means force is directly proportional to the product of m1 and m2. So he included two basic things in his law. He said force is directly proportional to mass through the product of mass m and mass m1 and mass m2. And then the second point he told that force is inversely proportional to the distance. Let's say I took distance as r square. For your convenience, the points that I want to tell you, it is not necessary that it is given in book, therefore you will take the same variable, same alphabet. No, not necessary. You may take whatever you want, a b c d e f g. But why are we taking these types of variables, or why are we taking these variables? Because there are some variables, let's say small g, big capital G, then a. These all are having their own value. Like a denotes acceleration, P denotes momentum. So that's why we should be quite careful about taking the perfect variable for our numerical. Alright, so these are the very two important things that Newton told. What did he told? Force is directly proportional to the product of mass. Force is directly proportional to the product of mass. And second thing, force is inversely proportional to the square of the distance. Now what does it mean? What does it exactly mean? What do you mean by this? So now let's see force. Okay, let's take force as F. Now it is directly proportional to the product of m1 and m2. Now what is m1? m1 is 50 into 60 kg. Okay, it is directly proportional. Okay, so force directly proportional to 50 into 60 is 3000 something, right? 3000 kg. Now it is directly proportional. Directly proportional means if the force is high, if the mass is greater, or if the mass is high, then the force applied will be high. If mass is high, then force applied will be high. But if mass is low, for example, this pen is there, it is having a low mass as compared to this highlighter. So I'm having two things, I'll be explaining with it. But if mass is low, then the force between that object is also low. Okay, now see, this is a pen, this is a pen, and this is the highlighter. Now see, as I took 50 kg, so I will just take this as 50 kg, you know. Don't like all, I know it is not 50 kg though, it's in gram, maybe 50 gram or something, but I took 50 kg. Now let it be. Just think, now this pen is for what? This pen's mass is 50 kg, and I took it here, I placed it here, and the mass of this highlighter is, let's say, 60 kg. So they both are having the force of attraction between them. Though we cannot, though we know they cannot attract each other. You know, if they are having attraction force, then they should attract each other. Like we are attracted towards the earth, they should stick each other. But why they are not sticking? Because the force of attraction within them is extremely less. You know, it is almost 0 point something something. 0 point something something Newton. Always the force between the objects is too less, that's why they don't attract. But the force between a human and earth is so much that's why the human is able to attract towards the earth, and that's why earth is pulling person or any object. Okay, but these are not attracting, they possess gravitational force. Newton told that these are two objects, this is 50 kg object, this is m1, this is m2, and force between them is directly proportional. Matlab is in between these two there is a force of attraction, that there is a force of gravity. Now who is having more force and who is having less force? Now this is of 60 kg and this is of 50 kg. So what we learned, higher the mass, higher will be the force of attraction between it. So this is having higher force of attraction as compared to this pen. And if the mass is low, let's say this pen is having less mass, that is 50 kg, so it is having less force of attraction than this highlighter. All right, so it was all about the first thing, so we are cleared about this. Okay, simply if you understand these two things also now, then you will be able to derive this equation which I wrote here, F equals to g m1 upon m2 upon d square. So here I took variable as d, but here I took variable as r. I should have taken the same variable, but alright, my bad. Now the second thing, now what is the second thing saying? Force is applied. Force is something we don't know what is it. Force is inversely proportional to the distance. Now what is distance? Distance is 2 meter, and we take 2 meters square, means what? Force is inversely. Now see, you might get confused ki how you can say this is directly, how you can say this is inversely. Why? Because see, whenever inverse is told, whenever someone is telling ki this is inversely proportional, at that time the main thing, at that time the one is added in numerator. That's why we come to know whether that object is directly proportional or whether that object is inversely proportional. Okay, so this force is inversely proportional to the distance square. Now what is the distance? Distance, let's say, of course 2 square means 4, sorry, 2 meter is the distance, and so 2 square will be 4 meter. Now what is this 1 upon 4 meter? I will tell you. It is the amount of force. Now here what it is said, if as they are inversely proportional, if the distance is high, if the distance is high, let's say 4 meter, 4 meter is a huge distance, right? If the distance is high, then the force of attraction will be less. Higher distance, less force of attraction, and higher and less distance, then higher force of attraction. Now let's see, this is the pen. Okay, let's take this example only. This was the pen and this is the highlighter. If I place them nearer, at that time they are having the high force of attraction. Why? Because see what they have said, as distance is less, so the force will be high. But if the distance is widened, then the force between them is less. Now what is this 4? So why do we have to make it as a square? So basically what it is said, let's say if the distance is of 2 meter, then how much force is decreased between that object? Understanding my point? Now here this is the object, this is the object, the distance is 2 meter ka distance. Now you want to calculate how much force is there. So you can find by using one formula, but that formula we will learn like not now, but we'll learn later on in this video only. So 2 meter. Now let's say force is something x, so that force is less. As the distance will increase, then that force will be decreased by x upon x into 1 upon 4. Now why 1 upon 4? Because see, we took 2 square means 4. If here it is 3, matlab either hai, this is here, this is here, so the force will be what? It will remain what it is said. When I kept this over here, then it will decrease. If I kept here, it will decrease. If I kept here, it will decrease. And when I'll go as far as I can, then the force of attraction will gradually decrease. So first I kept here, I took the square, so I kept it 4 meter. So the force of attraction will decrease by 1 upon 4. If it is 3 meter, then I took more 3 meter. What it becomes? 3 square is 9. So 1 upon 9. By 1 by 9, this force of attraction is decreased. Okay, so these 2 points are all cleared. As the surface, I have taken my science book, which is extremely worst in condition, so don't mind it. Now we are apparent or clear about the concept of these 2 things, because this were the important one. This was the important one. Now let us move to the formula. So first what we saw that F is directly proportional to the product of M1 and M2, and it is inversely proportional, means when we will multiply 1 upon a d square, let's take d square, so 1 upon d square. So thus what we obtained that F is directly proportional to M, product of mass 1 into product of mass 2, like the product of both the masses, upon d square. All right, are you all clear with this idea? Hope you're clear. Now you might be knowing, or if you don't know, it's okay. In first chapter, we learned the derivation of Newton's second law of motion, that is momentum, F equals to mm. We learned how to derive F equals to mm. At the time, we learned if we want to remove this proportionality sign, then you have to multiply by a constant, and at that time we took any constant. But in NCERT book it was taken K, and I took any of the constant that I want, and the constant is having only one value, that is 1 in case of second law of motion. But here what we are having proportionality sign. Now when we will remove this proportionality sign, we will multiply the constant g. Now see, if I took this, then F equals to, I want to remove the proportionality sign, so therefore I used equal to multiply by g. Now g is a constant with a constant value, let's say g, and then same formula, g m1 m2 upon including g d square. Okay, and in that formula what we learned, this is what we learned. Okay, now I will tell you the formula of, I will tell you the value of g. Now see, what is g? G is nothing but it is the universal constant. It is the universal constant. Now this constant is having a particular value. And what is that value? That value is 6.67 into 10 to the power minus 11. Now, why only this value is assigned to variable g, that we are gonna learn in the next part of the video, and that would be uploaded soon. Most students wonder what is g, so I will again tell you what is g. G is nothing but it is the constant. It is not any force, it is nothing like constant number, like constants variables that we use in math. It is just like that, and it is having no formula, nothing else. It only has a fixed value, that is 6.67. and why are we using that 6.67 value, sorry, 6.67 into 10 to the power minus 11 value? We are using it as a constant. Now why? Because see, this value was not actually invented, discovered or invented, discovered, let's say okay, invented only na. So this value was not invented by Isaac Newton. Instead, it was invented by other scientists. In his whole life, Newton tried to find the value of this thing, but he was not able to do it. But after 70 years of his death, a new scientist approached or arrived, and he found the value of g, that is the universal constant. Now what is its Newton? Sorry. What is its unit? Instead of saying Newton, I said Newton. Okay, I want to say what is its unit. Its unit is kg. Oh, sorry. Newton meter square per kg. Newton meter square per kg. Now what does this value indicate? We will be learning in the further video, because it's too time consuming, and also to derive the value of g, it takes a lot of time, and I won't be able to explain neatly in this short video. Alright, now we got the point that how we got the value of F. So this is nothing but the formula for gravitational given by Newton. Now here we are gonna take one example for our convenience. So question number 1. What does the question number 1 says? It's very easy. So it is given mass 1 is 2 kg. Mass 2 is also 2 kg, and the distance between them is 1 meter. Distance between them is 1 meter. Now we have to find force of attraction between M1 and M2, and we have to find the force of attraction between M1 and M2. Now we know what is the formula to find the force of attraction. So what was the formula? Yep, it was F equals to G, product of M1 and M2, divided by D square. Alright, now what was the force? We don't know, so we will take it as F equals to G is what? 6.67 into 10 to the power minus 11 into M1, that is 2, and M2, that is 2 upon 1. Now let's solve it. Now 6.67 into 10 to the power minus 11 into, we take this as 4. Now see, there's no need to write 1 in the denominator, because we all know it doesn't have any value, so no need. Now see, it's quite, now you will multiply this 4 with the 6.67. 6.67 into 4. 7 4s are 28, 2 6 4s are 24, 25 26, 2 6 4s are 24, 25 26. What we get? We get 26.68 into 10 to the power minus 11. Now see, what we will do, we will try to convert it into the more simpler form. Now see, 10 to the power minus 11, it means what? It means like this, okay? 2668, and this is here point. पॉइंट इधर है तो यहाँ से 11 काउंट्स, मीन्स 1 2 3 4 5 6 7 8 9 10 11. So 4 equals to, oh wait a minute, oh then we will get this only na, then 4 equals to shit, we'll get this only 26.68. So what we will do, we want one point over here, because mostly we take point after the one digit, after one digit, not the after one digit. So we will we will take 11 from this 2, means you will increase 1, so it will be what? 2.668 into 10 to the power. Now see, 1 2 3 4 5 6 7 8 9 10. अरे यार, मैंने क्या कर दिया ये? So 10 to the power minus 10 will be the answer. Okay, you just convert this into the you just convert this into this decimal form, and then again try to convert that decimal form into the another fractional form, in which the decimal point should come after one digit. And if you know that, you can do, just don't follow mine. If you want to multiply this, 4 with into 10 minus 11, you may do that. There is no restrictions. I just was a little bit confused, but if you know how to solve this, you may solve. You may not copy me. All right, so the force of, so this, what we can conclude, therefore the force between m1 and m2 is 2.668 into 10 to the power minus 10 Newton. Okay, now here I want to tell you one thing. Now see, for when you will convert this into decimal form, like this is an exponential form right now. When you will convert this into decimal form, you will get something 0.00000268. So it is like almost 000. So you can you think, will it have any force of attraction within it? No, of course not. And if the value is in zeros have no value, right? If 0 is independent, then it is not having any value. If it is dependent, it is having value. And here you may solve some numericals from Google, from your reference book, and any other thing. It was just the introduction and derivation. Hope you like this video. If you like, please don't forget to subscribe my channel and stay tuned for more video like this. Bye, and see you in the next video.